Okay, part 2, we've got another cumulative frequency curve to draw. So 16, 50, 84, what am I on about? 82. Then we've got 96, 100. Going on to plot, minimum value could be 0 seconds, so we'll say 0 calls took that long. And then we're going 10 to 16. So 1 square is going to represent 2 seconds. We've got 50. We've got 82. 90, 6, 100. Okay, this time we've got to use a graph to estimate the number of calls that took more than 18 seconds to answer. Oh, we've got to draw a curve, and that would actually help, wouldn't it? Oops. Not my best curve. Hopefully the examiner won't mind too much. Okay, so we've got to use a graph to estimate the number of calls took more than 18 seconds. So we find 18 seconds on our time axis, draw a line up, and then across to the cumulative frequency. Whoops, sorry. So it looks like 42 calls took less than 18 seconds, or 18 seconds. So we had 100 calls in total, so 100 take away 42 leaves us with 58. So that's 58 calls took more than 18 seconds. "200 students took a test. The cumulative frequency gives the information about their tests." There you can see it. So the lowest mark scored in the test was 10. They want us to use the information in the cumulative frequency graph to draw a box plot showing the information. So what we can do is mark on the lowest and the highest scores for our box plot first of all. So the lowest score was 10 and the highest score was 60, so we've got each end. But now we need to know our upper quartile, lower quartile, median. So let's go to our cumulative frequency curve for the rest of this information. We know that there are 200 students in total, so the median will be the 100th student. I'm going to draw a line across from 100 on the cumulative frequency axis, the y-axis, and then a line down. So I'm going to go with 10, so that's 37. So our median is 37. If we go back down to our box plot, 35, 6, 7. I'm going to draw a line at 37, so there's our median. And then if we go back here, we need our lower quartile, which is going to be the 50th person. Now it looks like each square is representing 4 people, so that means that 44, 48 is going to be right in the middle there. Lovely. Yeah. Oops. So I'm going to go with that being to the nearest whole person at least 30. So now if we go back down here, we'll draw a line at 30, that's our lower quartile. And then we need to find our 150th person. So 60 take away 4, so that's 58, 54, sorry 150, yeah, 154, so it's going to be about there. Oh, sugar. So that is going to be 43rd person, so 43. Back to here, 40, 1, 2, 3. And then we draw the box, joining our upper and our lower quartiles. And then we draw a line from the lower quartile to the median and the upper quartile to the maximum. Okay, last question. On Friday, Peter went to the airport. He recorded the number of minutes that each plane was delayed. He used the results to work out the information in the table below. Draw a box plot. Minimum was 0. Maximum was 41. Lower quartile was 2. Upper quartile was 18. Oops. And median was 8. Let's turn it into a box plot, join the upper and the lower quartiles. And then lower quartile to minimum, upper quartile to maximum. Peter also went to the airport on Saturday. He recorded the number of minutes that each plane was delayed. The box plot below was drawn using the information. Make 2 comparisons between the distribution of plane delays on Friday and Saturday. So we are going to make 1 comment about the median and 1 comment about either the interquartile range or the range in general. So on average, fewer planes, on average planes, were not as late on Friday because the median is lower. And we can also say on Friday the planes were more consistent with the amount in the time they were late. Delayed, sorry. Shouldn't say late. Delayed was the right answer. They're more consistent in the amount in the time they were delayed because the interquartile range is lower. Something along those lines, 1 mark for each. And that's it.